All right, guys.
I hope you had a good.
Spring break.
On the sidewalk.
Sometimes flat surfaces can be a challenge.
It's because I missed the step and I went, oh! I'll play hide and seek. Oh, I can figure that one out. I can do the math. Oh, I can do this one for sure.
Here today. I don't know.
All right, guys. So, chapter 6. We've covered most everything in chapter 6 except for chapter 6.6. 6.6 is the last thing we're going to cover in chapter 6. Now, we didn't cover it before spring break mainly because I didn't feel we had enough time to cover it and go over the review test, do the whole thing there. So I moved it to after spring break. So the only thing we haven't covered in chapter 6 is solving, because we've talked about properties, we've talked about it, all the other parts, 6.1 through 6.5, except for graphing, but we're not going to worry about that there. So the last thing we have to do in chapter 6 is to solve. And the first one we're going to look at with solving is, the textbook here calls it the property of equality for exponential equations. It's also referred as the one-to-one property. And what that property states is if b is a positive real number other than 1, then b of x equals b of y if and only if x is equal to y. If the bases are the same, the exponents have to be also. If the bases are the same, the exponents have to be equal. Because here, the only way 5 to the 3 minus 2x is equal to 5 to the negative x is if 3 minus 2x is equal to negative x. If the bases are the same, the exponents have to be equal. If the bases are the same, the exponents have to be equal. Questions on this here? Solve for x. So what can we do first?
Oh, shoot. Oh, you got that. Oh, that.
We want to get x by itself. Negative 2x plus 2x is 0. Telling us 3 is equal to
2x. No, x.
negative 2x plus x, or 2x plus negative x, or negative x plus 2x is 1x, or x. So x is equal to 3. You're good? And if we wanted to check this, we could. We could say 5 to the 3 minus 2 times 3. 5 to the 3 minus 2 times 3. And we get 1 over 125. The other side is 5 to the negative x, so 5 to the negative 3. There's also 1 over 125. So x is indeed equal to 3. Questions on this here? Let's look at the next one. 6 to the negative 2a is equal to 6 to the 2 minus 3a. Since the bases are the same and we only have 1 on either side, it means that the exponents have to be equal. It means that our negative 2a has to equal to minus 3a. So we would add 3a to both sides. Minus a is equal to 3 minus 2 is 1. So 3a minus 2a is just a. A is equal to 2. And the nice thing for these first few here is that they made the solving after we set them equal to each other kind of nice. We just move the 1 over and we're done. But that's it.
What classes do you offer? What do you call it? College classes, I guess?
College algebra.
That's it.
Mm-hmm.
College.
Yeah.
So we don't do calc?
We don't have enough to offer calculus or that go that far, and at that point, most is, if you're going to take calculus, you're taking it because you're going into an engineer or math-heavy field.
Right.
And at that point, you're going to take an AP course most likely instead of just that, or
Kind of pre-cal is part of the calculus itself.
here nor there.
I feel like that's only
Pre-cal is essentially algebra 2 with trigonometry. So it's law of sines, law of cosines, more trigonometric. A lot of it's just formulas. Number 4, 3 to the 2a is equal to 3 to the negative a. Since the bases are the same, the exponents have to be equal. So our 2a is equal to negative a. We can add a to both sides. 3a is equal to 0. Now there's two different ways we can go about doing this, because we do need to solve for the value of a. But if we have two or more things multiplied together to equal 0, one of them must be.
So what can we minus the 2a?
Yeah. And that would, instead of giving us 3a equals 0, it would give us negative 3a equals 0. We can divide by negative 3, and we get a is 0. So either way, a is 0.
I did that in my head, but it's weird when you did that.
Yeah, so we could subtract 2a and it would get to the same spot. Questions on these here? Yes.
PPD is in school. PPD in the paper.
What are you talking about?
Be quiet over there, buddy.
Problem number 8. 2 to the 2x plus 2 is equal to 2 to the 3x. 2x plus 2 is equal to 3x. Now, since the bases are the same, we set the exponents equal. Now we need to get x by itself, yes? So we would do what? From both sides. 2x minus 2x is 0, leaving us with 2. 3x minus 2x is x. If we added, it would be 5x, and that would give you the...
Oh, that's where I got that.
Yep.
Okay.
Yeah, for the most part, these here have been simplifying quite nicely. I mean, even if it had been negative 2x instead of positive, we would have added it, then divided.
I just need to get back in the spring break. I looked at, I worked so much this week that I looked at my calendar thing, and it's like the 25th, and we have a bunch of food that goes up at work today. So I was going to call it this.
Be good with all these so far, yes?
I get started.
Let's look at the next one. The bases are the same, yes? And we have one base on either side. We have 2 on one side. Now, if we're multiplying like bases, we can do what to the exponents? We can
Square them.
add them. Because when you multiply like bases, you can add the exponents. Because if we're going to use this property, this one-to-one property, we have to have one base on either side, and they have to be the same.
Oh, that's what I thought. So we don't even square, or we don't even multiply the ends. We just.
So 6 to the 3m times 6 to the negative m. When the bases are the same, we add the exponents. So for us, we'd have 3m plus negative m. Well, 3m plus negative m is just 2m. Questions on this here? Because again, for this one-to-one property to work, the bases have to be the same, and we need just one on either side. Now, since the bases are the same, and there's one of them on either side, it means the exponents have to be equal. So 2m is going to equal negative 2m. So what do we need to do first? We need to get the variables on the same side, yes? So we can add 2m first. Now we could divide by 2, which would just tell me m is equal to negative m, but we want them on the same side. Because our 2m plus 2m is 4m. Negative 2m plus 2m is...
Oh, so if there's a number, this is like simple algebra. If there's a single number without a variable,
We get it on one side, we get the variables on the other.
then we have to divide.
Then we would divide, yes.
That's like simple.
Yeah, since our variables here are just to the first power, we don't have an exponent attached with them, we get it by itself.
So it's like equaling it to 0.
So we solve for it. We just solve for that variable. We don't have to get it equal to 0, everything on the same side.
I think that'll help.
Yeah. Here it worked out we got it equal to 0 because there was no constant term. There's no term without a variable. So questions on number 9. I feel kind of comfortable with that. That's not too bad. We just need to get it as a single term on either side. Well, that's kind of handy to know because for 13, 4 to the negative 2x times 4 to the x, since we're multiplying like bases, we can add the exponents. So our 4 to the negative 2x times 4 to the x would be 4 to the negative 2x plus x. And since the bases are both the same, we can set the exponents equal to each other, yes?
Calculated? They're not the same calculator.
Well, our bases are what? 4 and... But it would be nice if both of the bases were 4, yes? Can we rewrite 64 as 4 to a power? And what would that power be?
3.
So 4 to the third is indeed 64. So we could rewrite 64 as 4 to the third because we want those bases to be the same. Now our negative 2x plus x is negative x. So with rewriting 64 as 4 to the third and simplifying the other side, we do now have an equation where the bases are the same. And since the bases are the same, the exponents have to be equal. So we're saying negative x is equal to 3.
So it's just x is equal to
Yeah. We can divide by negative 1. We could have also multiplied by negative 1. Either one would work. Because our negative x times negative 1 would be positive x, and 3 times negative 1 is negative 3. Same thing with dividing. Questions on this here? But the big thing with these here is just making sure the bases are the same, because once we get them to be the same, we can set the exponents equal.
It's going to be 1 over 10 squared.
So 1 over 10, yes? So we need the bases to be the exact same. So that means we're going to have to rewrite 100 and 1 over 10 so that they are the same. Now the 1 over 10, we can actually move that number from the bottom of the fraction to the top. But to do that, we have to take its exponent and make it negative. Now since there wasn't an exponent written there, it means it was 1. So we move it to the top, it is now negative 1. Now we do need to rewrite 100 as 10 to a power. Okay? 10 squared, 10 to the second power. Questions on how we did this here? Are the bases the same? Yeah, and that's the main goal, because if we can get the bases to be the same, then the exponents have to be equal. Now before we set them equal to each other, powers of powers multiply. So our 10 to the second power to the x, our 2 and x multiply together, giving us 10 to the 2x. Our other side, we're going to distribute that negative through. Negative 1 times x is negative 1x, negative x. And our negative 1 times negative 3 is positive 3. So our negative 1 times x minus 3 turns it into negative x plus 3. Questions on this here? Since the bases are the same, the exponents have to be equal. Which is telling us that 2x is equal to negative x plus 3. I believe so. So to get there, what would we need to do first? Add x, because since there are variables on both sides, and our constant term is only on one, we might as well add x first. Telling us 3x is equal to 3. And then lastly, we can divide by 3, telling us x is equal to 1. Be nice. Be nice.
Just kidding.
Okay.
Questions on this so far?
Think about what y'all
Go
think.
put your nose in the fire. Go move your clip to the right.
I would actually get like so mad when they go back to the doctor. They're like, no, I'm not calling your mama. Please don't call my phone.
Questions on this here? Let's look at the next one. Now, with this one here, unlike the last one, we could try to get these both to the base of 9 or base of 3. Either one works. Because it works out 3 squared is indeed 9. And it ends up being 3 to the 4th is 81. So if 9 didn't work, we would go to 3. Because if it had been, say, 27 instead of 81, we can't write 27 as 9 to a power. So then we've got to drop down. But again, the whole goal is to get these bases to be the same. And it works out 9 squared is indeed 81. So it could be, and this is again, this is where Algebra 2, college algebra would differ, is that they would actually set one up where we have to actually move both of them down and not just one. Does that make sense?
Next year stuff?
Yes, possibly. Now, just like the last one, powers of powers multiply. So here we'd have 9 to the
2x.
is equal to
9 minus 6. Or, minus 6. I wrote that down on my paper.
because our powers of powers multiply, so 2 times x would give 2x. Negative 1 times our x plus 3 would be negative x minus 3. Since the bases are the same, we're going to set the exponents equal to each other. So what do we need to do first? Which will tell us that 3x is equal to negative 3. Divide by 3, and yes. Questions on this here?
How did my pencil get so dull? I'm trying to pick up our beer. It is. Oh my gosh.
Now, last one of this here. So, what we're hoping to be able to do is rewrite 243 as 3 to a power. Because the other side, 3, that's as simplified as it gets. We can't reduce or rewrite 3. So 3 to what power do we think is 243?
2. Five. No. Yeah.
Yeah.
Oh. It's actually 5.
It's actually
It's actually 4.
Oh, it's 5.
It's actually
5.
4. Oh. I thought we were going for 64.
Because 3 to the 4th would be 81.
Okay. No, don't say that.
Since the bases are the same, since the bases are the same, the exponents have to be equal. Now we just need to solve for x. And what's the first thing we can do? We can subtract 1. Since the variables are already on the same side, we need to get the constant terms on the other. Because our 1 minus 1 would be 0, leaving us with negative 2x is equal to 4. And then we would by negative 2, telling us x is equal to negative 2.
I'm writing it, I can't write it.
Questions on this here? We good with everything so far? We ready for the next part?
What?
Property of equality for logarithms, or one-to-one, the one-to-one property. If b, x, and y are positive real numbers, so they can't be 0 and they're not negative, with b not equal to 1, then log base b of x equals log base b of y if and only if x is equal to y. So if the two logarithms are the exact same, then what's inside the logarithms have to be equal. So here, we do have one log on either side, and they are the exact same log. So it means that 4x minus 7 has to equal solve for x. So what do we do first?
We add 5. We minus 5. We
We
actually add x.
Mine, what the heck?
We,
Pick one.
oh, right.
God dang it.
Because we can minus 5 from both sides first. We could have added 7 to both sides. We could have subtracted x or subtracted 4x. We needed to pick one of those 4. Since we subtracted 5 first, it'll tell us that 4x minus 12 is equal to x. Because negative 7 minus 5 would be negative 12. Now, since we don't have x to an exponent, we don't need to get it equal to 0. So we can move the 4x
Oh, okay.
to the other side by subtracting it, telling us negative 12 is equal to 3x. What can we do next? By?
12.
We would divide both sides by
Negative 2.
Okay, it'll be 4.
negative 3, because our negative 3x divided by 3 would be x. Negative 12 divided by negative 3 is?
Negative 4.
4.
Not negative. Negative divided by negative.
Is a positive. Negative divided by negative is a positive. And I mean, we could have done it in different ways. If we added 7, subtracted x, it would have just told us that 3x equals 12. Divide by 3, and we get that x is 4. So either way, we get to the same thing. We're ready for the next one. Natural log of 7x minus 4 is equal to the natural log of 2x plus 11. Since both of them have a natural log, we can set what's inside each of these logs equal to each other. So 7x minus 4 is equal to 2x plus 11. What can we do next? We can subtract 11 from both sides. And it'll tell us that 7x minus 15 is equal to 2x. And then we could?
Subtract 7.
We can subtract 7x. Because our 7x minus 7x is 0. Telling us negative 15 is equal to negative 5x. And last but not least, we would? Almost. Negative 5.
Got it.
Now, if it had just been 5x, we would divide by 5.
I don't know how I did it. I got the same answer. I don't know how I did it, but I didn't get any negatives at the bottom.
If you added 4 first,
Oh, that's exactly
and subtracted the 2x, or subtracted 2x, and then it would give you,
I'm moving it from this to then this.
yeah, it gives you 5x equals 15, divide by 5, and you get the same spot. So it just depends on where you start. You'll get to the same place.
This is lightly dated.
Questions on this here? Now, before we move on, if I told you to evaluate e to the ln of 4x minus 7, well, this would just be what? It would just be 4x minus 7 is the base, so e to the ln would cancel. So if I put both of these sides to the base of e and ln would cancel, leaving us with 4x minus 7 is equal to x plus 5. That's why this works. Same with this here. If we put both sides to the base of e, those cancel, telling us 7x minus 4 is equal to 2x plus 11.
I think they would just put that on there just to confuse us.
Let's look at the next one. ln of 5x plus 2 equals ln of x plus 10.
Let's do 5x plus 2 equals x plus 10.
Yes.
We would subtract
So 5x minus 8 is equal to x. And the next thing we can do is subtract 5x minus negative 8 is equal to negative 4x. And lastly, we would divide by negative 4, telling us x is equal to
What?
She's doing all right.
questions on this here.
I'm sorry.
What about the next one?
Maybe.
Oh, we got this. Like, we,
Log of 5x.
it's both log, so it's just 5x equals 2.
Yes.
Yeah, I was right. I got you before.
Because since the logs are the same, what's inside has to be equal. 5x equals 2x plus 9. What can we do first?
Subtract 5x. No, yes.
I'd go the other way.
Oh, 2x.
I would subtract 2x from both sides. And the reason I would subtract the 2x is because our constant term, the term without a variable, is already by itself. Let's get the variables on the same side. So 3x is equal to 9. Then we would,
Your mother's here too.
I'm here to say
so x is
3.
and that's it. And at any point, we could plug these back in and check them, and they would work out to be the same, because the natural log of 5 times 2 plus 2. ln of 5 times 2 plus 2. And our other one's the natural log of 2 plus 10.
That was last year.
So even though they're decimals, they are the exact same value, so it does work. Questions on any of this here?
Yeah.
Now I did notice, or kind of was pointed out earlier, that this one has x instead of v. Still works out to be the same. Log base 12 of x squared plus 35 is equal to log base 12 of negative 12x minus 1. We wouldn't have to, because are the logs the same? It's just log base 12. So just like the last one, this is just telling us that x squared plus 35 is equal to negative 12x minus 1. Because if the logs are the same, one on either side, then what's inside of them must be equal. Because even though the base is 12 and it gave us that base, really what we can say we're doing is adding a base 12 to both sides, because our log 12 to the log base 12 on both of them would simplify out, leaving us with x squared plus 35 is equal to negative 12x minus 1. And this here is our first quadratic, x squared. And with our quadratics, we've got to get this equal to,
We add one.
Oh, so can we minus x squared?
we could, I try to keep the x squared positive, because if we have to factor it, it's easier to factor it if the term in front of x squared is positive.
Because I just did that and it was a negative.
Right, then we could fix it later.
Okay.
Because if we add 12x, we have x squared plus 12x plus 35 is equal to negative 1. Then we could add 1, telling us x squared plus 12x plus 36 is equal to 0. Now we do have several different ways to solve this here. We could graph it, we could factor it, or we could use the quadratic formula. If the number in front of x squared, the a value is 1, I'd go on and graph it.
X plus 6. X plus 6.
And we get this here, and tells us x is negative 6. Yes, now if we factored it, it would indeed be x plus 6 times x plus 6. And whenever we have two or more things multiplied together to equal 0,
X plus 6 and x minus 6. Or negative 6. So we wouldn't leave it at the factor, we have to do that.
because once we factor it, we use the zero product property that states that any two things multiplied together to equal 0, one of them must be 0. So x is negative 6.
I don't know why we go through this factor.
Yeah. Factoring works just as well.
I usually don't have a calculator either.
But was that much harder than the one we just did? No.
I would lose my head with
Get a Tesla.
for a stop.
An electric calculator.
They're all.
Because most
It sounded funnier in my head.
most calculators, I mean, you can do, the graphing calculator does help a lot, but not necessarily necessary.
The calculator's gonna die. I was like,
So you have these 10 problems for homework.
But it's normal for me.